take a quick look at this question. Question 13. On Monday, Xander and Tristan each received some money from their mother. We have two boys, Xander and Tristan. But do we know the amount of money they received? Perhaps continuing to read the question will help us. Xander received $80 less than Tristan. The word less refers to the first person mentioned in this sentence, which is Xander. This means that Tristan had more money than Xander. Let's quickly use the model to visualize this. Now, what happened next? They did not spend any money on Monday. On Tuesday, Tristan gave Xander 40% of his money. Let's pause and reflect. We now have an at first, which is Monday, where Xander and Tristan received money. A change, which is on Tuesday, where Tristan gave 40% of his money to Xander. This follows a common problem-solving method called change strategies, and we use the ACE method, which stands for at first, change, and end to help us. Thinking about what changed can sometimes feel overwhelming. Instead of focusing only on the change, try asking yourself, what stayed the same? A quick introduction to the 4 types of ACE problems. First one item stays the same. We will see later on in the second change in the question on Wednesday, where only Tristan spent 25% of his remaining money. The second one, total stays the same. It is where the total amount doesn't change, but there's a transfer between two persons, just like this question, where Tristan gave 40% of his money to Xander. The third one, difference stays the same. This commonly applies to age kind of questions. The last one, everything changes, where nothing remains constant, which is also not relevant in this question as well. In Primary 5 questions, we are usually lucky enough to deal with just one change. But for this Primary 6 question 13, it is not that simple. If you continue reading, on Wednesdays, Tristan spent 25% of his remaining amount of money on a wallet which cost $39. If you guess that this falls under the one item stays the same category, you are right. Now that we have two changes, let's set ourselves up for success by first indicating change 1 and change 2. Also, we can help ourselves by outlining our work clearly, splitting our paper into 2 sections, which will give us space to organize and visualize both ACE changes effectively. Now, let's fill in the information from the question into our setup. From the very beginning, it was a great idea to draw a small model to help us visualize the problem. Now let's transpose this information into our ACE framework. The blank units that are equal in the model are usually known as 1 unit. At first on Monday, Xander has 1 unit. Tristan has 1 unit plus 80. Referring back to the question, on Tuesday, Tristan gave 40% of his money to Xander. This marks change 1. At first, 40% may seem overwhelming, but converting it into a fraction can help us to solve this question. How do we convert a percentage into a fraction? Remember, a percentage is simply a number out of 100. So, 40% is equivalent to 40 out of 100. The numerator, 40, represents the portion Tristan gave away. The denominator, 100, represents the amount Tristan originally had. Let's apply this to our at first values from Monday. Instead of working with 1 unit, let's express their money in 100 units for easier calculations. So, Xander has 100 units, whereas Tristan has 100 units plus 80. Now let's handle change 1, which is Tuesday. Tristan gave away 40% of his money. 40% of 100 units is 40 units. 40% of $80 is $32. Both 40 units and $32 are transferred from Tristan to Xander. Can we now determine the total amount at the end for this ACE? Of course, it's as simple as basic subtraction. At the end of change 1 on Tuesday, Xander will have 140 units plus $32. Whereas for Tristan, he will have 60 units plus $48. Now that we have completed the first ACE setup, we are ready to tackle the next stage of the problem. Let's set up our second ACE. Since nothing changed at the end of Tuesday, the amount from Tuesday's end will be carried over as Wednesday's at first value. Let's copy this information now. Now, let's return to the question to identify change 2. On Wednesday, Tristan spent 25% of his remaining money on a wallet which cost $39. Let's fill this information into our setup. Since this part of the question focuses on Tristan, it also tells us that nothing changed for Xander. So, we can copy and paste Xander's amount from at first Wednesday to the end of Wednesday, and note under the change column that Xander remains unchanged. On Wednesday, Tristan started with $60 and $48. Tristan spent 25% of this remaining amount on a wallet. So how many units would that be? Let's calculate. 25% of $60 is $15. 25% of $48 is $12. Now, let's determine Tristan's final amount by subtracting what he spent. So at the end of change 2 on Wednesday, Tristan's final amount would be $45 plus $36. We also know that the total amount Tristan spent is the same as the cost of the wallet, which is $39. Let's form an equation for this wallet, whereby $15 and $12 equates to $39. Using a model, we can see this equation easily. We have a total of $39, and this is made up of $15 and $12. So to arrive at $15, we simply remove $12 from $39. This leaves us with $27. Always find one unit, and we will get $27 divided by $15, we will get $1.80. Do not panic when you see a decimal here, since we are dealing with money. Always go back to the question to ensure we answer it correctly. The question asks, what was the total amount of money Xander and Tristan received on Monday? Thankfully, we label all our working, so it's easy for us to find the answer. From our first ACE setup, Monday at first, Xander had $100, whereas Tristan had $100 plus $80. Adding them together, the total amount received is 200 units plus $80. Now, substituting 1 unit equals to $1.80, we should arrive at a total amount of $440. To answer the question, the total amount Xander and Tristan received on Monday was $440. This question falls under the change strategies technique, which consists of the 4 types mentioned above. In this problem, we applied 2 of these strategies. Although this question is from the topic of percentages, the same approach can be applied to other topics such as whole numbers, fractions, ratios, and decimals.